Okay, so today we're going to be looking at the ideal gas law when you're solving for density. Now there are two equations you can use. You can use Pervnert, which is what I'll be using, or you can use a shorter equation and you'll get the answer quicker this way. But today I'll be using that like I said. Now, let's break down Pervnert. This is what each letter equals. The P equals pressure, V equals volume, N is the number of moles, R is the gas constant. So in every problem, it will be this number. And then lastly, temperature for T. Now, in parentheses, I have the units that you'll need. So if you're giving something different than ATMs, liters, moles, or kelvins, you'll have to convert before you start solving. Now today, I'll be using this problem. And it says, there is an unknown amount of nitrogen gas when there is a pressure of 2.60 atms, temperature of 287 kelvins, and a volume of 1.5 liters. What is the density of nitrogen gas? So let's fill in the blanks with what we know. So if we look in the equation, it first tells us that the atmospheres are 2.60, so we can fill that in. Next, V, like I said earlier, is volume, so we'll have 1.5 liters. Now, if you see, it doesn't say anything here about grams or moles, so we're going to leave that blank, put a question mark right there, because that's what we'll be solving for. Then, like I said, you'll have the gas constant for R, right there. Won't change for any problem. And then lastly, we see temperature is 287 kelvins. Now, you can look at the units for each one, and it's what's needed for Pervnert, so you won't have to do any type of conversions. Okay, so let's take what we know, and let's plug it into the equation. So you will have this as your equation when you set up Pervnert. PV equals nRT. Okay? Then your goal is to get n alone, so you'll take this and divide it by this, and then you'll get n. So when you enter that into your calculator, you will get n equals 0.1655, and then I put a ... here because that just shows I'm going to let those numbers run in my calculator, which I suggest you do for a more accurate answer. So let's move this all over now since we started getting the hang of it. And then next, because since we're solving for density, and density is grams over liters, you're going to want to convert this to grams. So when you do that, you will do a conversion here now. You'll have the moles of nitrogen times grams of nitrogen gas over 1 mole of nitrogen, N2. So these moles here will cancel out, and then you'll multiply straight across. Now when you do that, you will have this as your answer. You'll have 4.637, leave the numbers running, grams of nitrogen gas. Now, as I've said, to find density, you need grams over liters. Now, if you remember in the problem, it says that the liters is 1.5. So we're going to use that and take the number of grams and divide it by the liters. Now, when you do that, you will get 3.0918, and there'll be more numbers running, but I cut it off here because that's all we need. And then nothing cancels out, so you'll have grams over liters of nitrogen gas. Lastly, you'll have to look back at your problem one last time to determine the number of sig figs. Now here you see that there's 3 sig figs here, 3 here, and 2 here. And you look for the least number, which in this case is 2, and that's what you need for your final answer. So you'll have to round 9 up to 1, and for your final answer, you'll get 3.1 grams over liters of nitrogen gas is the density.